this question, we are told or given that the line AB has equation 3x minus 4y plus 5 is equal to 0. The point with coordinates P and P plus 2 lies on the line AB. Find the value of the constant P. So if it lies in it, I can sub in the x value of P and the y value of P plus 2 into here, and obviously form an equation in terms of P and then solve it. So I have 3x, so 3 lots of P, so 3P, minus 4 lots of Y, so minus 4 lots of P plus 2. Okay, close the brackets and then copy down here the plus 5 is equal to 0. After that, guys, we are going to expand the brackets and obviously collect like terms. We've got 3P, then we got minus 4 times P, so it makes minus 4P. Then we have minus 4 times plus 2 makes minus 8. Copy down the plus 5 is equal to 0. Okay, I'm now going to collect my like terms. So 3P minus 4P makes minus P, or negative P. Minus 8 plus 5 makes minus 3 is equal to 0. I'm going to add P to both sides. We get minus 3 or negative 3 is equal to P. Therefore, P is equal to minus 3. And then minus 3 plus 2, so minus 1. Okay, so that's the first part done. Next up, find the gradient of AB. The gradient, okay, to work it out, I'm going to rearrange it in the form y is equal to mx plus c, where m is our gradient. Okay, so the value of m is our gradient, and c is our y-intercept. Okay, but we're focusing on m. So I'm going to add 4y to both sides. So I have 3x, sorry guys, plus 5, or add 5 is equal to 4y, or 4 lots of y. I'm going to divide both sides of my equation by 4. Okay, we get 3x plus 5 all over 4. Okay, or quarters is equal to y. I'm going to split this up now here into y is equal to 3x over 4, or 3 quarters x, you could say, plus 5 over 4, or 5 quarters. What's the number in front of the x? It's going to be 3 over 4, or 3 quarters. The gradient of AB, guys, is 3 quarters, okay, or 0.75. But it's best to leave it as a fraction. Okay, next up, guys, next part. The point A has coordinates 1, 2. The point C has coordinates minus 5k. Is such that AC is perpendicular to AB. Okay, very important. Find the value of k. So, if AC is perpendicular to AB, that means the gradients must multiply to make minus 1. Or in other words, okay, it's the negative reciprocal of one another. So the gradient of AB is 3 quarters. Then the negative reciprocal will be minus 4 over 3, or minus 4 thirds. Okay, so now I'm going to write it in the form y is equal to minus 4 over 3, or minus 4 thirds, or negative 4 thirds x plus c. Now, how can I work out my c value? Well, I can sub in the coordinates of A, okay, because obviously AC means obviously it lies on that point. So y is 2, x is 1, so 2 is equal to negative 4 thirds times 1, minus 4 obviously times by 1, plus c, obviously anything times 1 here is going to be itself. So now 2 is equal to minus 4 thirds plus c. I'm going to add 4 thirds to both sides. Okay, think of 2 whole as 6 over 3, or 6 thirds. Okay, 6 divided by 3 makes 2. I'm going to add 4 thirds. Therefore, c is equal to 10. Okay, are we done, guys? Nearly. Okay, all we do now is obviously, now we know what c is. We can now sub in our coordinates for c. Is in here, capital C in here, into this equation to work out the value of k. coordinates which is equal to 30 divided by 3, which is 10. So k is equal to 10. So capital C here has the coordinates minus 5, 10. Okay, but k is equal to 10. Okay, that's the third part done. Okay, so we're nearly there now. Okay, last point now. The line AB, okay, which is obviously given to here, the part question, okay, intersects with the equation 2x minus 5y equals 6 at the point D. Find the coordinates of D. Well, we're going to solve a pair of simultaneous equations, okay? So I'm going to copy down here the 2x minus 5y is equal to 6. And then I'm going to rearrange the equation of AB in this similar format. So all I'm going to do here is I'm going to subtract 5 to both sides. So I'm going to have 3x minus 4y is equal to minus 5. Okay, I'm going to label equation 1 and equation 2. And I'm going to solve them simultaneously because where they intersect, okay, the x and y values are going to be the same. Okay, so obviously I'm going to solve it simultaneously. So yeah, I've got one of two options. Yeah, I can times the top equation by 4, second one by 5, or times the top equation by 3, and then by 2 to eliminate the x. Okay, I'm going to try and eliminate the x here just for my purpose here. I'm going to times the top by 3, and the second equation by 2. Okay, what we're going to get, guys, well, we're going to get, let me just delete this, sorry, yeah, okay, sorry about this, I apologize. A lot of us, we're not going to have any more space here, I apologize. Okay, but you're able to obviously rewind here to obviously copy any bits down. So, we're going to have 6x, or 6 lots of x, minus 15y is equal to 18. Okay, so times the top equation here by 3, and times the second equation by 2, so we're going to have 6x minus 8y is equal to minus 5 times 2 makes minus 10. I'm going to label this as equation 3 and equation 4. Okay, and I'm now going to do equation 3 minus 4, 4 minus 3. It doesn't matter which one you do. So 3 minus 4, but obviously be very careful with your signs here, guys. Okay, so 6 minus 6, obviously that's going to go. I've got minus 15y and I'm subtracting minus 8y, so it becomes minus 15y plus 8y makes minus 7y, okay, is equal to 18 minus minus 10 becomes 18 plus 10, which becomes 28. Divide both sides of my equation by minus 7, we get y is equal to minus 4. I'm going to plug this now into equation 1. Okay, doesn't matter here whether it's 1 or 2, 3 or 4. So I'm going to have 2x. Then I've got minus 5 times minus 4 makes plus 20 is equal to 6. Subtract 20 on both sides and then divide it by 2. We get x is equal to 6 minus 20 and makes minus 14. Divided by 2 makes minus 7. Okay, so the coordinates of D, guys, is going to be minus 7 minus 4. Okay, and that, guys, is working with equations of straight lines on the AS Pure Maths course. So for year 12 students and year 13 students. Okay, this is from the old spec, AQA A-level papers. Okay, from the core 1 spec. Okay, but yeah, definitely quite like like a question with like a lot actually going on. Okay, but do practice and obviously revise any bits in this video. Okay, but yeah, there's obviously quite a lot actually going on here. But in total, we've got what, 3, 6, 7, 8, 9, 10. So 10 marks awarded for this coordinate geometry question, which may well come up here in this year's AS exam, or even A2 exam. Okay, whether you're year 12 or year 13. So on the full A level, or even the end of year 12 exams or year 12 assessments. Okay, thank you very much.